To understand the future of our civilization, we need to consider how to defend against asteroids. Picture a gigantic asteroid hurtling through space, on a collision course with Earth. This isn't just a movie scenario, it's a real threat lurking out there. 66 million years ago, an asteroid wiped out the dinosaurs. Today, NASA is tracking a potentially catastrophic asteroid heading our way in May 2024. Astronomers are deeply concerned because if an asteroid of similar size were to hit Earth now, it could spell the end for us. NASA is urgently working to divert its path, but why worry? Well, consider past incidents like the Tunguska event in 1908 and the Chelyabinsk meteor in 2013, which caused significant damage. Asteroid impacts aren't just about size, speed and composition matter too. Most asteroids are rocky and may break apart before hitting Earth. But metallic ones, though rare, pose a bigger threat as they often remain intact. NASA's OSIRIS-REx mission landed on an asteroid named Bennu in 2018 and returned samples to Earth in 2023. Studying Bennu is crucial as it has a chance of impacting Earth in the 22nd century. Another mission, Apophis Pathfinder, aims to land on the asteroid Apophis to study its composition and trajectory. Apophis was once considered a major threat, but further analysis ruled out any danger. NASA's strategy includes sending spacecraft to collide with asteroids to test defense methods. The DART spacecraft will hit a smaller asteroid, testing the kinetic impact method. This experiment will help understand how to deflect asteroids in the future. So, while Hollywood loves asteroid disaster movies, the reality is that we're actively working to protect our planet from these cosmic threats. And with continued research and innovative missions, we're hopeful for a safer future. HARA will carry research gear to check out the damage caused by DART. It'll snap lots of pics of the asteroid, especially focusing on the spot where DART hit. HARA will also release 2 tiny CubeSats, smaller than a show box. These little satellites will get closer to the asteroid and study it for 3 to 6 months. One of them might even try landing on the asteroid to learn more about what it's made of. Plus, HERA might bring a mini-impactor to hit the asteroid again. Scientists want to compare how a big spacecraft hitting an asteroid differs from a smaller one. This will help us figure out how to defend against asteroids better. We don't necessarily need a giant rocket to destroy a dangerous asteroid. Even a small hit could change its path. A small change in an asteroid's path could make a huge difference. But hitting asteroids isn't the only way to deal with them. Another way is using something called a gravity tractor. Instead of crashing into the asteroid, a spacecraft orbits it. The asteroid's gravity pulls the spacecraft, but its engines keep it at the same distance. Over time, this could move the asteroid away from Earth. But it only works if we find the asteroid years before it might hit us. There's also using a powerful laser. When we spot an asteroid, we aim a laser at it. The laser heats up a spot on the asteroid, making it evaporate. As the material evaporates, it pushes the asteroid in the opposite direction, like a rocket engine. And we can even use solar power. By focusing the sun's rays onto a spot on the asteroid, we can make it evaporate and change its path. It's like using a giant magnifying glass to burn something, but in space. Or we could wrap the asteroid in reflective material. This would make it reflect the sun's rays and gently push it away from Earth. If all else fails, we can attach rockets to the asteroid and blast it away from us. With enough rockets, we might even be able to control where it goes. Tracking asteroids is like playing a high-stakes game of dodgeball. We're constantly watching out for big ones, especially those wider than 0.6 miles. But don't worry, the chances of a big asteroid hitting us in the next 1,000 years are low. Asteroid collisions are rare, but when they happen, they're powerful. Just one asteroid hitting Earth could have the same impact as thousands of nuclear bombs. That's why scientists study them closely. And it's not just Earth that's been hit, impact events have left marks all across our solar system. Even our closest star neighbor, Proxima Centauri, has some mysteries. Scientists thought they detected a signal from there, but it turns out it was likely just radio interference from Earth. These signals may seem strange, but they help us learn more about space and how it works. And who knows? Maybe one day we'll pick up a real signal from another civilization out there in the cosmos. The magnetar slowed down to less than its usual speed in just 9 hours after a glitch. That's way faster than usual for these kinds of events. Normally, it takes weeks or months for a magnetar to go back to its normal speed after a glitch. Qin Ping, an astrophysicist at National Tsinghua University of Education in Taiwan, who led a new study, said, "Clearly, things are happening with these objects much faster than we thought before. This might have something to do with how fast radio bursts occur." When scientists try to figure out how magnetars make fast radio bursts, they have to think about a lot of things. Magnetars are a special kind of neutron star, packed with so much matter that a teaspoon of their stuff would weigh as much as 1 billion tons on Earth. Because they're so dense, they have really strong gravity. If something light like a marshmallow fell onto a regular neutron star, it would hit with the force of an early atomic bomb. This strong gravity makes the surface of a magnetar really wild. It's always shooting out bursts of X-ray and even higher energy light. Before the fast radio burst in 2022, the magnetar started giving off bursts of X-rays and gamma rays, which are even more energetic than X-rays seen by special space telescopes. This increase in activity made the operators of these telescopes point them straight at the magnetar. Even though all those X-ray bursts before this glitch had enough energy in theory to make a fast radio burst, they didn't explain everything. So it seems like something changed during the slowdown period, creating the right set of conditions, said Zhou War, a scientist at the University of Maryland College Park and NASA's Goddard Space Flight Center. One possibility is that the outer layer of a magnetar is solid, and the inside is squished so much that it becomes like a superfluid. Sometimes, these two layers can get out of sync, like water sloshing around in a spinning fishbowl. When this happens, the fluid can give energy to the crust. The researchers believe this is probably what caused both glitches that came before and after the fast radio burst. If the first glitch made a crack on the surface of the magnetar, it might have let out stuff from the star's insides into space, like a volcano erupting. When things leak out, spinning objects slow down. That's why the scientists think this could explain why the magnetar suddenly slowed down. But since they've only seen one of these events happen in real time, the team can't be sure which of these things could cause a fast radio burst. Some might not have anything to do with the burst at all. "We've definitely seen something important for understanding fast radio bursts," said George Eunice, a researcher at Goddard and part of the NASA science team studying magnetars. "But I think we still need a lot more information to solve the mystery completely. Radio signals from outer space are not a new thing, but only now are we beginning to understand them better thanks to technological advancements." Back in the early 1930s, a physicist and radio engineer named Karl Jansky was employed by Bell Telephone Laboratories to investigate interference in their transatlantic radio communications. In a surprising twist, Jansky discovered a powerful radio signal coming from outer space, specifically from the direction of the constellation Sagittarius. This accidental discovery made Jansky the unexpected pioneer of radio astronomy. Since Jansky's groundbreaking find nearly a century ago, astronomers have been tirelessly scanning the skies, searching for new sources of cosmic radio waves. Fast forward to late November 1967, when Jocelyn Bell Burnell, a postgraduate student, and her team were working with a newly constructed radio telescope at Cambridge University. While meticulously examining the data, Burnell noticed an unusual signal. Upon closer inspection, she identified a series of repeating radio pulses occurring exactly every 1.33 seconds. This was unprecedented. No one on the research team could explain the origin of these radio pulses. There was even a whimsical suggestion that the signals might be transmissions from an alien civilization, humorously named the mysterious signal LGM-1, short for Little Green Men. However, the discovery of a second pulsating radio source on December 21, 1967, quickly debunked the alien hypothesis. It wasn't extraterrestrials, but Burnell had nonetheless stumbled upon a Nobel Prize-winning discovery. In 1968, the Cambridge team published their discovery of a fascinating new object, which they named a pulsar, short for pulsating radio source. A pulsar is a unique type of neutron star, an incredibly dense remnant formed from the explosive deaths of massive stars. These stars die in spectacular explosions called supernovae, leaving behind a core so dense that a single teaspoon of its material would weigh billions of tons on Earth. A neutron star has a powerful magnetic field that funnels radioactive particles from its surface into two tight beams. These beams shoot out huge amounts of electromagnetic radiation as the particles are accelerated to nearly the speed of light. What makes neutron stars even more extraordinary is their rapid spin. Most neutron stars rotate incredibly fast, completing a spin in just a few seconds or even milliseconds. When the beams of a neutron star are aligned in such a way that they point towards Earth during each rotation, we see these flashes as a pulsar, much like the sweeping light from a lighthouse beacon. Since Jocelyn Bell Burnell's pioneering discovery, astronomers have found over 2,000 pulsars scattered throughout the universe, each one a cosmic lighthouse guiding our understanding of the stars. Thanks to the tireless work of NASA and dedicated scientists, our glimpse into the cosmos is becoming clearer every day. These experts are like cosmic detectives, solving the mysteries of the universe piece by piece. Their relentless efforts are turning the once blurry view of the stars and galaxies into a sharp, vivid picture. Now, we can explore the wonders of space with greater detail and understanding than ever before. Keep watching Scientific Thoughts for more interesting episodes.